Let us do one more numerical on the de Broglie's dual behavior of matter. It says if the kinetic energy of the electron is 3 into 10 to the power minus 26 joules, find the wavelength associated with it. Now what we are given is, we are given kinetic energy of the electron, and this which is 3 into 10 to the power minus 26 joules. We know kinetic energy is half mv square. So basically he is trying to make us calculate the mass and the velocity from this value. But what we can do is, since we know the lambda is h over mv, we can put the values of the mv here and we can find out how this lambda is associated with kinetic energy. So when we solve these two equations, like this one, kinetic energy is equal to half mv square and lambda is equal to hv, we get a formula, direct relationship, which says h is equal to under root of twice of m ke, where m is again is the mass of the electron or the particle, and k is its kinetic energy, which is visually associated with the particle. So we can use this formula directly to find out the lambda associated with any particle having kinetic energy ke and having mass m. So now we know kinetic energy is 3 into 10 to the power minus 26, and we know the mass of the electron is 9.1 into 10 to the power minus 31 kg. Kinetic energy is this much, so our lambda is h over 2me ke. How we can write this? It will be h is 6.626 into 10 to the power minus 34. So it will be square root of twice into 9.1 into 10 to the power minus 31 into 3 into 10 to the power minus 26. So we can find out it will be 6.626 into 10 to the power minus 34 upon this will become almost your 18.2 into 10 to the power minus 31, and 26 will make it 57 into 3, the square root of this. We can find out again, we can change this into 6.626 into 10 to the power minus 34. Then we can have 1.82 into 10 to the power minus 56 into 3. We can multiply it by 3, so what we can get is 6.626 into 10 to the power minus 34. The square root we can do finally, square root of 1.86 is 1.34 into 3, square root of 3 is 1.732, and 10 to the power minus 56 will come out to be 10 to the power minus 28. So when we solve this, what we get is approximately is 4.9 into 10 to the power, because 28 will go above, will make it 4, and 6 will make it minus 6 upon 1.73, which will come out to be your approximately 2.9 into 10 to the power minus 6 meters. So this is what is your answer is. So this is how we can easily find out the lambda, the wavelength associated with any particle which is having certain fixed kinetic energy which is given to you in the numerical.